Hi, I'm Esther.
And I'm Sean.
I write about AI news here at TechTarget.
And I edit Esther's stories.
We're here to talk to tech experts about everything AI, from open and closed models to AI agents and who's ahead in the generative AI race.
And even the elusive AGI.
We've got it covered, right, Sean?
Yep, we've got it covered.
Hello, everyone. Welcome to another Targeting AI podcast. Today's guest is Karen Panetta. Karen is an IEEE Fellow and Dean at Tufts University. Karen was the worldwide director for IEEE Women in Engineering from 2007 to 2009. She has also received several NASA and National Science Foundation research grants. She was awarded the Presidential Award for Science and Engineering Education and Mentoring in 2011 by former President Barack Obama. 2 years ago, she was inducted as a National Academy of Engineering member. Thank you so much for joining us today.
My pleasure.
Okay, so good morning. We're going to discuss AI ethics today. But first, we want to know, how did you get your start in engineering, and how did you get into software engineering?
Well, so just so you know, I had no idea what engineering was, but I was really good at math and science. And my father said to me, "You have a very expensive shopping habit, so you need to be able to financially support yourself. So you're going to become an engineer." What that meant, I didn't know, but I went to Boston University, got a computer engineering degree, and I thought, oh, I built computers. And that's what I did for a long time, is I designed CPUs. And then finally, I joined IEEE, and I got to interact with people from all around the world. And that's when I learned that my skills really could be used for other things, especially when I came from, I was in industry. And then when I came to academia, I was shocked that there were no women. And then they said, we're hiring you to be a mentor for women. And then when I got to my first class, there were no women. So that's how I would say I became an accidental mentor and proponent and champion to bring inclusive audiences to engineering. And I saw that the way the curriculum was built, it really, the exercises and labs were smashing concrete. They weren't conducive to everybody. And I love to give the example that if we said today we're designing high heels, boys and girls, you'd hear a lot of complaints. But if we say today we're designing sneakers, well, that just makes it balanced for everybody to enjoy. And that's really the key, is getting everyone on the same leveling the playing field so that everybody can participate and enjoy what they're doing.
I love that because obviously I've been in this for like almost 4 years, and you're right, it's not like in the sciences, there's not a lot of women, especially in tech. So I wonder how your passion for making sure this inclusivity in engineering transfer over to like AI and tech.
Sure. So, a lot of the times what you see every day, we wake up and you say, I see this problem. Why hasn't anybody fixed this? Right. And that's really what engineering is. I always start out with that, because it's not about wondering, what math am I going to use? What AI am I going to use? But it's more about, how am I going to solve this problem? And what is the problem? And is it really a problem? So a lot of engineers design things that'll never be used because they didn't have an actual audience in mind, that they understood what they needed. And that's where I see AI right now is jumping in, is it's got this huge potential, and everybody's trying to throw it at everything. And that's why I think it's getting good press and bad press, because if you throw it at everything without a directed strategy of why you need it or what you want it to accomplish, you're wasting your time. And then you also end up with things that, with bias, or that give you a determination that is wrong. And if that can affect someone's health or their livelihood, or, create, separate us and make us not work together, that's a bad thing. So that's where I got into the artificial intelligence realm. And my first jump into it was trying to help recover children from human trafficking. And what I noticed was all the data sets that were trained out there for facial recognition were, taken straight on, both ears showing. And in the real world, cameras are mounted high, there it's nighttime. And the database was all, mostly taken from people of color and criminal databases. So that was like, okay, there's bias right there. And I wanted children. So what we did was we created the world's first most diverse database, which had ages from 3 all the way to like 78, from people from all around the world, to be able to look at them with sunglasses on, with masks on, different rotations of the head, because AI trained with very pristine data is not going to work in the real world. And I think that that's something a lot of people forget, is real world does not automatically translate to AI.
Yeah, thanks for that. So correct me if I'm wrong, but I think you're known for co-inventing a CPU digital twin. So what is a CPU digital twin? We've done some coverage of digital twins, yeah, omniverse kind of stuff. So what is the CPU digital twin and what does it do?
Sure. So back when I worked for a company called Digital Equipment Corporation, we would build new computers. So one of the things that would happen is, as you got smaller and smaller with billions of transistors, how do you test that? How do you actually simulate that? So it was my job to come up with efficient simulation algorithms to be able to explore that. And it wasn't just building it so that you could have a representation of all the different transistors in it. We wanted to artificially break it. So because we were developing tests and diagnostic tests at the same time for hardware that doesn't exist yet. So what we wanted to do is saying, if the machine breaks in this way, can you find it and isolate it, detect it and isolate it? So what we did was built this model, and it was huge. And yet I only had at that time, one CPU. It was before threading existed. And you're looking at this expansive space of potential, billions of scenarios that you have to look at. And I came up with an efficient way to do that. So the twin itself is a replica, a simulated replica of the computer. But then what we did was we loaded on this computer, this artificial simulator, we loaded the software on it to see how the diagnostics tests would run. And that helped us for manufacturing to be able to manufacture chips that would be able to detect the problems. And when I got to university, they said, well, it doesn't make any sense to test the chip. If it's broken, you just throw it out. Like, but the question is, how do you know it's broken? Right? So that was the big one. And you don't go and build an entire computer and then say, oh yeah, the chip's broken, let's throw out the whole computer. So that's how I got into digital twins. And now you see it for everywhere. And when I went to NASA, what I loved about what they did was you had a software twin controlling an engine, a real jet propulsion engine. And you'll see that now with more what we call hybrid systems, where it's a piece of software controlling, that you're building out this twin of what the real hardware will look like, but it's controlling multiple real live physical hardware.
Just a quick follow-up about digital twins. Do you see a strong market for that technology in the future? Not, but right now it's mostly in like industrial applications or science. Do you see any other real-world popular applications for that technology?
Absolutely, absolutely. People they seem to think is AI and then there's simulation. I'm of the mind that you need both. And in the future, as an educator, I'm really looking at how can we use digital twins for learning, and or to or simulating expert environments. So I'll give you an example. I also have an appointment here at the School of Dental Medicine. I'm not a dentist, but I'm using AI to help train future radiologists. So what we're doing is we're using AI and eye tracking and your audio to be able to look at something and figure out how you diagnose it. And then we can compare that to the expert. So we're looking at how is an expert analyze this. And so we start out with a real live expert to train the model. So that's our model is based off a real expert. And then of course we compare and contrast what the student learned to, like, what were they looking at? Did they zoom in on the right thing? Did they have the same diagnosis as the expert? This allows us to build, a real expert model of how someone would review in scans, what they look for, and where they spend their time looking. Because students tend to zoom in on one artifact, where an expert, goes in and they're looking at everything. And using the eye tracking, we can see that. So starting from a human, modeling that human, and then moving to, it's not a full digital twin of the human, but that's one aspect. The second aspect is I do a lot of modeling of human systems, because to me the human system is the ultimate true test. So one of the first things that I did when I moved from industry to academia was I came in saying, why do we do all this image processing to help people perceive information better? The sensors that you're taking, a camera has way more information than a human can perceive, and our job is to present that to you. So by modeling and creating a digital twin of how a human eye sees, that helps me understand how to create the most optimal visual image to present to a human being. And that's how, and I also looked at the operators and I said, human eye doesn't work this way. Why do we expect the computer to work that way? And bridging that gap really helps significantly.
Thanks.
That sounds awesome. I want to ask an aside question because as you're talking and you're talking about what you're doing with the technology, I feel like I have to ask because you are a dean of a university as well. How, as a dean of a university and someone so closely related to the technology, do you, I guess, perceive AI when it comes to student relation?
So I'm here at Tufts. I'm the dean of graduate education, which means I'm
Sorry.
responsible. No, that's okay. It's a population of graduate students doing research. So I think AI is even more pronounced here because any master's or PhD student is doing research. It's a research oriented discipline in engineering. So, how do we use AI? Most people think of it in undergraduate as like they use it to write their paper. They used it to summarize things. I'm seeing it, I like to see it used as a tool. So for right now, when I'm writing a grant or I'm writing something, I find that drawing the diagrams is like the death of me. But if I can describe what I want and then even get a template, even if it's not beautiful, it gives me something to work with. So I'm finding that AI as a tool is very helpful. What I don't find it helpful for is, you see a lot of people say, oh, I'll use it to write code. I haven't found it, useful in that sense, because the code that it gives me is going to take me more effort to get it to work right, or to do what I really want, or to provide me the security, the infrastructure that I really wanted. So in the university, I think it's a good tool to sort of explore the space of, I'm looking for the top, papers in quantum mechanics or in, robot vision. And hopefully like it'll point me to like the IEEE archive of papers versus some social media post of something like that. So I'm finding that while I have to know the quality of what it's suggesting to me, like, what the places where's it's getting its information from. If it says it's coming from IEEE, then I'm like, okay, that's a vetted, well-known, respected venue. But if it just pops up something and gives me something and I don't know where it came from, that raises questions to me. And I think that's the whole problem right now with AIs. You don't know where stuff is coming from. And if it's just being scraped from the web, that could be social media sites. And that's why a lot of times, I use the joke in my presentations. I say, if we were to ask an audience, is Dracula really allergic or doesn't like garlic? What would the answer be? And if the answer is yes, and AI says, yes, he's allergic to garlic and doesn't like garlic, is that true? It's nobody asked the right question. So that's why I like to qualify by saying you have to know and have vetted sources.
That's definitely true. So we've discussed AI ethics on this podcast before, and what does AI ethics mean? For you personally, would you define it? What makes an AI system ethical? Also, how is responsible AI the same as ethical AI, and how does it differ? Sorry, lots of questions thrown at you there.
Sure, lots of questions. Well, let's start out by talking about just what means ethical. So ethical to me means that it doesn't do harm to people or their livelihood. It doesn't disparage people. It doesn't hurt. It's just like that do no harm. Whenever we have to do any sort of research, the number one baseline is do no harm. And I think that that's the number one thing. And ensuring that is kind of difficult in most cases. And the one I like to give the example of, again, speaking generically, is sometimes when you're surfing the web or something and you see something pop up for weight loss, they show you somebody's backside, right? They don't show you their face, but they show you their backside. It's a very large backside. And I often wonder, did they actually ask that individual, do you mind if I put your butt, on the internet for weight loss? And I know that I was like, if that were my butt, I would know it and I wouldn't want it on the internet like that. And that's an example because people think, well, it's not identifiable, right? But you've hurt somebody. The internet might not know who the person is, but that person certainly knows who they are. And to have somebody say that looks like you, that the surroundings looks like outside your office, and is that you? That's embarrassing. So being able to have collecting the data with people's permission and understanding how it's going to be used. Just because I'm not showing your face doesn't mean that there's no other identifying factors. So that's number one, is ethically collecting the data, making sure that you understand it. The second one is, how are you going to use it? So again, using somebody's person or their likelihood or their, something that looks like them, or in a harmful way to make money, or to disparage, or to just things like that, that's doing harm. Even social harm, it might not be back to that specific individual, but it's using for not the benefit of humanity. That's the way I would put it. So when we talk about ethical AI, we're talking about how we collect it, the rights of the people, and also how we're going to use it, and disclosure of that when you actually do use it, that this image was used. I think the other one about responsible AI is being to be able to explain it. So it's not just, well, I collected this data, but if I then go and say, oh, Esther, your performance evaluation using AI said you are deficient, therefore you're going to take a pay cut. And you're like, why? What did I do wrong? There's that's not responsible. They haven't given you reasons. No, I'd say, well, that's because the AI says so. That's not acceptable. And it's not responsible. And I think that that's really what we're talking about, is when AI makes a decision, it is not responsible for the output, especially if it's wrong, that it does damage to people's lives. And also, can you believe it? So you've seen a lot in the press with deep fakes, being able to emulate my voice, emulate my face. And it's convincing. They can make people sound horrible and do whatever they want. And people tend to believe it. Well, the superstar, rich movie stars and singers can go out and they have a whole legal team to go rescue their reputation. But you and I, that happens to us, we're destroyed. We don't have that financial infrastructure to combat irresponsible uses of AI.
All right, that's really interesting. So continuing with AI ethics, how does the conversation around ethics change when you extend it into agentic systems and agentic AI, which is the huge buzzword right now?
Yeah, agentic AI is, it's really saying that multiple models of AI can talk to one another, and they can all act autonomously and do their little expertise. So again, I'll use the analogy again from most system design. Things fail at the interface boundaries. So while we have a lot of different types of security applications, now that you've got all these different models running in an agentic system, what ends up happening is, I might be dedicated in working on one small task of automation, and then I might have this coordinating, controlling AI overseeing and looking and everything, and everybody's communicating back to me. But the big thing there is, how secure is it? Because if it's not secure, if one small piece isn't secure, then the whole system falls apart. And I'll give you an example. Back when I started doing simulations and I got a brand new printer, I had my machines taken over and I couldn't figure out how they got in. They went into a guest account on my printer. And you're like, wow, your printer. They can actually break your system by getting into your printer. The cyber criminals aren't going in the front door. They're finding the weaknesses in the systems. So if that means some sensor that's communicating data to another model or something like that that's not secure, that's gonna cause a problem. And then you're gonna have these, could even be catastrophic takeovers of systems, reporting wrong data. And you have to have what I would call like the all-knowing eye that's looking out, an overarching cyber infrastructure in your agentic system, overlooking all this, to make sure that if it sees anomalies, it can detect them. And right now we're not quite there. Everybody's just putting the pieces together right now. So it's a new area. It's a big buzzword, but security is really going to be the name of the game.
Informa TechTarget has covered the lack of diversity in tech, particularly regarding women and people of color. You have obviously strove for gender diversity in your engineering career. How important is diversity when we're talking about AI systems? Why must creating these systems be diverse? Why must those creating the systems be diverse? And how does that inform the technology itself?
I started out this conversation by saying when you design something and you don't understand who the population or the people that it'll be serving, they won't use it. and and I think a lot of times one of the problems with technology is they assume that they know your problem and they know what your everyday is, and that's not the way diversity works or diverse populations work. One of the examples I always give is when I was in high school. Again, one of the few women interested in science. We had to do an experiment where we had to drop an egg from a roof, and you had to come up with an apparatus to do it. And I used pantyhose in my design to suspend it. And you think about that, it's like, how many guys are going to use pantyhose, right? They're not. Now they do, because now they see, oh, right, because somebody's already done the design. They do the research. But back then, everybody laughed at me. It's like, oh, she used pantyhose, but I also used a cardboard box, the pantyhose. It was cheap. It was low cost. Everybody else came up with these beautiful, expensive designs. It worked and it was cheap. And to me, it was like innovative. And I think that that's exactly what we lose when we don't have diverse populations, because the way you grew up or the way, you learned to do something might be very different than somebody else. So, and I also heard that, using pantyhose was a way to keep the sand from getting in guns in military operations, in deserts. Well, again, what guy's going to come prepared with pantyhose? So it really looked at the fact that that's a gender example, saying why we need different genders. But I also think it extends itself very easily to different backgrounds as well, because when you see people, I've seen so many projects, humanitarian projects, where they would say clean water, right? We understand clean water, malaria, all these different types of diseases, where you'll have engineers build these beautiful devices to filter the water. They're solar powered, they're beautiful. And then we see that the people that they're supposed to serve don't know how to maintain them, or that they're not using locally sourced materials. They're intimidated by the technology. And if you had designed with that in mind, then you would have come up with a design that was more conducive to the population that you were going to help do that. And the only way you're going to get that is, you might think, well, I'm just going to go ask them questions. But having design team people members on your team, I think, is important. The final example I use is the crash test dummies. Women were probably still predominantly the purchases of minivans or for with children. And the crash dummies were modeled after, a 5'10" male at 165 pounds. And that's not the average for the woman. So again, was safety and concern, and it took that type of perspective to say, we're not designing for the customer. And even in the toy market, right? Look at the toy market. Girls, we got dolls that, were nurturing and you change their diaper. Boys got the architecture, right, to do all these other things. So when we finally said, girls are a huge market, why are we not offering them the same things? That's when that perspective came into play. And that would have never come about if there wasn't diversity and inclusion on the teams.
Okay, great. So the flip side of AI ethics, I guess, is AI bias. So we hear that a lot about that. So what is it, as you define it, and how is it changed since generative AI exploded? Has it become a bigger problem, a same problem on a different scale? And what are some of the risks AI bias creates, especially in the era of generative AI?
Sure. So, again, everybody forgets that artificial intelligence has to be trained. So what you're training with is an example. So it's almost like a child growing up learning only one thing or only one way. And, whatever your parents' values are, you become your values. Whatever you're told about somebody becomes what you believe. AI is pretty much the same thing. So I'll give you some examples. We were doing some nutrition and health diagnosis. And one of the things that the data we were collecting was like over 25 years old. And if you look at the population it was trained on, I mean, they were predominantly smokers. They were, mostly male, and they were looking at like heart disease and things like that. Well, that's very different, and it was all from one area. So if you're looking at access to nutrition or what's going on, so I can't take a model of data and train my model with data from the affluent city of Boston, most educated people in the world, health habits or whatever it is, and then expect that that's going to, you know, um, map to somebody in Ghana that's got no access to water, food, or in some place with, with conflict going on. So this is where the bias creeps in, is the model is constrained to model the experiences that it's seen. So if you don't bring in those diverse experiences, and one of the practical ones I'll give you right now is, again, with the dental school, we can't ask somebody, why do you have such bad teeth? What's going on here? And then you look at it like, well, look, they don't, their community doesn't have access to fluoride. They don't have access to fresh produce, things like that. You can connect these factors in to understand that, but not if it's not in the data set. So you have to be able to gather those experiences that represent everybody that you're going to be trying to make a diagnosis about, or to find some insight on.
I love that everything you're talking about here is about data, right? Because I think you and others will agree that it really comes down to like the quality of the system comes down to the quality of the data that you have. And I think that just to make a comment here, what I've noticed is at the beginning of the Gen AI, it seems like the data was just being scraped from everything off of the web, and now it's kind of has been refined a little bit. We're trying to see a little bit data conservatism when it comes to data. Um, how much attention do you think vendors are paying attention to this topic of AI ethics, especially when it comes to like the data that they're gathering and making sure that there's not inherent bias in their systems?
It depends what they're selling. I think, one of the things that I always train people on is that even if you don't know anything about AI, what you should know is, when they say this is 100% accurate, it's 99% accurate, you have to ask two critical questions. One was, how much data was it trained with, and where did the data come from? So, when I run a research team, my students will come in and they think I always want to hear like, our algorithm's the best. And they'll show me something and say, look, we got 100% detection. And even for me, I'm like, that doesn't sound right. And they're like, how many test cases did you work with? How much data did you have? Oh, I had, 10 test cases or something like that. And you're like, no, 10 test cases doesn't represent a population of billions of people. So I think that that's one of the things is there's a layer of marketing on top of it, and they're banking on that the public is going to believe them because they throw this 99% accuracy, 100% accuracy out there. And again, a lot of times these products, if you put them in human resources, for instance, to screen resumes, and we've seen this, they're going to say, here's the best candidates. And if you say, well, where'd you get the data from? Well, it was screened from the hires we made in the past year, and they all happen to be men that graduated from designer brand name institutions from the East and West Coast. Well, that's really biased, because it says if you come from the middle of the country, that your degree, it might not be valued. That's a bias. If you need to say that you have to come from a designer, one of the West East Coast schools, and anybody else in between is marked down for that, that's a bias. So a lot of people don't think about institutional bias, but it's there. So and companies will want to believe that, if they're selling something, that it's the best, and they want the customers to believe that. But when it fails, they have to be able to go back and say, yeah, this wasn't really, they have to qualify it and know where it's going to fail. And I think that having the customer discover the failures, that's what we always say, is like, do you really want your customer discovering the bugs? That some companies do. They're like, well, we'll fix it when it's out there and we see it. The other example is, you go into a bathroom in the East Coast and you try to wash your hands. It works for me because it was trained on people with light skin. You go in with darker skin, it fails miserably. And it's like, did they fix it? No. So, those are real life implications.
It's so funny with those things. I've always just thought it's not working. I never think maybe it works for someone else, and it just doesn't work for me. So good, good to know. But I wonder that what would you say is the error rate that we should be comfortable with? Because you were talking about like perhaps it shouldn't be 100% accurate, I think at the beginning. So is there a specific error rate that we should become?
I don't like error rates.
Okay.
What I want is it explainable? Can you tell me why you came up with this exam, this reasoning? And again, we saw this in security when, a lot of public cameras were pulling young people aside, mostly predominantly people of color, and because the facial recognition came up and said, yeah, this might be a potential, criminal. And you had all these people being screened, and that's traumatic to be pulled out of the line and things like that. And they might have said this was 99% accurate, but again, it was only tested with people of color. So if you can just, and then the error rate was very high. So while you would say, the error rate might give you some indication, I think that regardless of what comes out of AI, you need to be able to tell me why it made this decision. If it came out and said, well, you looked like some other person of color that was, an axe murderer, that's not enough evidence to pull somebody aside. So, there's things, or you don't deserve a promotion because the AI said so. Well, what were the metrics? What were you evaluating me on? Where was it? And if you can't explain it, and you can't point by point show me how I scored or where I was deficient, I don't care if it's 100%, because to me it's wrong, right? So they might say, well, this is accurate. We don't think you're any good, Karen. But to me, as a human being, I was like, no, that's wrong. That's wrong. And I give you another example. When I was in high school, we did computer generated assessment tests, and mine came back, even though I was number one in math and science, it came back and it said that I could be a teacher or I could sell cosmetics in a department store. Where my friend, who was a little bit lower than me in math and science, he could be the engineer or the politician or the scientist. And when I came back to the guidance counselor and I had my dad with me, they said, well, this was computer generated and computers don't make mistakes. And I was like, no, I'm sure, somewhere in that code there was, yeah, men make better, scientists and engineers, and women can go be teachers and sell makeup.
Okay, Karen, thanks. I apologize in advance for putting you on the spot, but I'm going to put you on the spot. President Donald Trump, his administration has proposed like really steep cuts in organizations you've been involved with, NSF, NIST, while also and also cutting research grants to university. So, not to get into partisan politics, but what is the motivation behind that, and what's your reaction?
Institutions have been doing the same thing for 100 years, right? The models that were instituted have become more cultural and institutionalized. Does that make them right? Does it make it wrong? So what's happening now is, and admit, you ask an administrator, I mean, I'm an administrator, but if you ask an administrator versus a faculty member, the difference, explaining why to to someone who's not in academics, if somebody says, well, if Karen gets a grant and there's a 60-70% overhead, which means the university is charging you a 60% overhead, that doesn't come to me as the researcher. It's not me is it really being directed to the research? And explaining that to the public, that's a hard thing to sell. Like, why does a rich university who's got billions in endowments, why do they need my tax dollar money to pay these massive overheads? And wouldn't you rather see the money go to the research? So I think that's the fundamental understanding. And again, being able to look at that, they say, well, it pays for the electricity, it pays for the different things. Well, how many times are you going to pay for that? Is it buying new equipment? It's the maintenance. But it's also being used to support all the peripheral services around the institution. So those overheads aren't going just to the research. And I think that's, looking at the high price tags that are tacked onto it, it's a hard sell to the public. What's going on, the reevaluation of some of these grants, I mean, it's very painful for a young researcher. It actually could be a death sentence to some of our young researchers that have their grants pulled, to say, well, you got this prestigious National Science Foundation Korea grant, which is like, a game-changing grant, and we're pulling your funding. So those are very harsh and those are hard. so, but there's a lot of opportunities where people are being able to, um, like appeal it, to talk about it, like why this fits the model or it doesn't fit the model. In some cases, I think the ones that are being hard to swallow is where there's being saying, no, you can't appeal it right now. So it's a very difficult, delicate landscape. But going back it's got to be a negotiation. At the end of the day, it's got to be a negotiation. And if they just think, the university's going to say, no, we're keeping our 70% overhead and we'll, just going to fight the government on it. I don't think that's a conducive way to move forward. I think that what's going on is it has to be a negotiation. And if the model needs to be revisited, which, it probably most likely does because it's been institutionalized for the past 100 years, then revisit it and come to the table. But I don't find it productive that they're not negotiating. There's not talk. We're all about talking about hearing different perspectives. And I think right now what I see is a lot of perspectives that's just like, oh, this is that people are going to die because we're not getting our 70% overhead. And I don't think that's the message. I don't want to scare people. There's people that are university. And I also look at it, industry for the longest time doesn't want to deal with universities because industry doesn't see why do I need to pay a 60% overhead to the university where I can hire a consultant? I'm taking one of your students and training them and giving them skills. Why are you going to charge me that where I could just go hire somebody or to do the job? So again, industry is resisting collaborating with institutions because they don't like the overheads either. So again, for every loss that we have, I see opportunity. I really see that there's opportunity. And I also think there's opportunities for those schools that aren't on the East or West Coast that don't have these very higher overheads to participate and jump in. And I also think faculty members, if you're going to take a job and it's going to say, well, I'm going to be writing grants for institutions that's going to take 70 or 70+% overhead, or I can go somewhere else that's not a big brand name institution where I can be a superstar and they're only going to take 30-40% overhead. That leaves me to do more research. I might not have all the resources that the big institutions might have, but it might be appealing to people. And I think that people aren't exploring these models. I think they're just too busy fighting each other.
Thank you.
Well, thank you so much, Karen, for being on the podcast. We really appreciate your insight and about AI bias and everything. Where can people find you?
You can find me at just go to on IEEE and search for Karen at IEEE.org. That's me. And you can also visit me on www.karenpanetta.com.
Can they connect with you on LinkedIn or anything like that?
Yes, they can. Yes, they can. Sure. Go for it.
That's great. Well, thank you to our audience, listeners, and viewers for joining this podcast. Please feel free to share, and just leave a review or leave a comment so that we can engage with it, as well as check out Informa TechTarget's targeting AI, Informa TechTarget's enterprise AI website, where we talk about AI ethics, AI bias, and everything AI. And we will see you next time on the Targeting AI podcast.
To hear the full audio podcast, please go to Apple Podcasts, Spotify, Amazon, Audible, TuneIn, Podbean, and other popular podcast platforms.